Welcome to chapter 4.3. Here we will study right triangle trigonometry. Right triangle trigonometry. And hopefully you guys have all seen right triangle trig in the past. What does right triangle trig pertain to? Well, it pertains to right triangles. And a right triangle is a triangle that has a 90-degree angle associated with it, okay? All right, so here we have a right triangle. We know this is a 90-degree angle because of this box that we have placed in the corner. It tells me that it's a 90-degree angle. And we have some angle, and we could call that angle theta, all right? Angles are generally labeled using Greek letters, theta being the most common that you will see. Now, we can classify each side of our right triangle with respect to our angle theta. This side here on the bottom, this would be our side adjacent to theta. That means next to theta. This side over here on the right, this would be our side opposite to theta. And this side over here is the hypotenuse. Notice that the hypotenuse is always going to be the side of the right triangle that is opposite the 90-degree angle. Okay, the hypotenuse is going to be the longest side of our right triangle and always opposite the 90-degree angle. So we can use the lengths of these three sides to form the six ratios that define the six trigonometric functions of the acute angle theta. All right, so we have six different trig functions. Our six different trig functions are sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. And to evaluate the sine, cosine, tangent, secant, cosecant, cotangent of an angle theta, we take the following ratios of the sides of the right triangle. To evaluate the sine of this angle theta, we take the ratio of the opposite side divided by the hypotenuse. To evaluate the cosine of an angle theta, using a right triangle, we take the ratio of the adjacent side divided by the hypotenuse. To evaluate the tangent of theta, we take the ratio of the opposite side of the triangle divided by the adjacent side of the triangle. And then notice our three remaining trig functions. Cosecant of theta is the reciprocal of the sine of theta. Reciprocal means that the fraction is going to flip, right? Reciprocal means 1 over. So instead of opposite over hypotenuse like we have with sine theta, cosecant theta is hypotenuse divided by opposite. Secant theta is the reciprocal of cosine. That means we take our ratio for cosine and we flip it. The secant of the angle theta is the ratio of the length of our hypotenuse divided by the length of our adjacent side. And cotangent theta is the ratio of the adjacent side divided by the opposite side. Notice that is the reciprocal of the tangent of theta. So in these equations, the abbreviations for opposite, adjacent, and hypotenuse represent the lengths of the three sides of the right triangle. So we're taking the length of each one of these sides, all right, as we plug them in. Now, you guys have probably all heard the acronym that allows you to remember these trig definitions, and that is SOHCAHTOA. SOHCAHTOA means that to evaluate sine, I take the ratio of the opposite side divided by the hypotenuse. To evaluate cosine, we take the ratio of the adjacent side divided by the hypotenuse. And to evaluate the tangent of theta, we take the ratio of the opposite side divided by the adjacent side. All right, so SOHCAHTOA, that helps you to remember sine, cosine, and tangent. Then we must recall that cosecant is the reciprocal of sine, so we need to flip that ratio. Secant is the reciprocal of cosine, so we flip the cosine ratio. And cotangent of theta is the reciprocal of tangent theta. Flip our ratio for tangent to get our ratio for cotangent. All right, let's do some examples here. Use the triangle shown to find the values of the six trigonometric functions of theta. Well, in order to evaluate the 6 trigonometric functions of theta, we must know all side lengths of our right triangle. Well, we have 2 of the given sides. How can we find the third side of a right triangle? We can use the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared is equal to c squared. The sum of the squares of the sides of a right triangle are equal to the square of the hypotenuse, all right? C squared, C always represents the hypotenuse. So in this case, we could say a squared plus 5 squared is equal to 13 squared. That gives me a squared plus 25 is equal to 169. I subtract 25 from both sides, giving me a squared is equal to 144. Take the square root of both sides of the equation, leaving us with a is equal to 12. Okay, now notice I don't have to worry about a plus or minus here because we are trying to find a distance. The length of this side of the triangle is a distance. It is always going to be positive. A is equal to 12. All right, so we label that side of our right triangle. Now we can evaluate our 6 trigonometric functions of the angle theta. How do we evaluate the sine of theta? We take the ratio of the opposite side and the hypotenuse. Well, here's theta. The opposite side would be 5. The hypotenuse would be 13. Therefore, our solution is 5 over 13. To evaluate the cosine of our angle theta, we take the ratio of our adjacent side divided by our hypotenuse. That gives us 12 divided by 13. To evaluate the tangent of theta, we are going to take the ratio of the opposite divided by the adjacent side. My opposite side is 5. My adjacent side is 12, giving me 5 over 12 for my final answer. All right, we're halfway there. Now, let's go to the reciprocal trig function of sine. The reciprocal trig function of sine is cosecant theta. Well, that means we just flip this ratio for sine. Cosecant theta is going to be hypotenuse over opposite, which gives us 13 divided by 5. The reciprocal trig function of cosine is secant. Secant theta is going to be hypotenuse divided by adjacent. Again, we flip our cosine ratio. Hypotenuse divided by adjacent leaves me with 13 over 12. And finally, the reciprocal trig function of tangent theta is cotangent theta. That is adjacent over opposite, which gives us 12 divided by 5. Let's try another one here. Given that theta is an acute angle and tangent theta is 4 over 5, find the values of the 5 remaining trigonometric functions of theta. All right, so we don't really have too much information going on here, but when in doubt, draw it out. Let's see if we can't draw out a right triangle that matches this given information. So we are told that the tangent of theta is equal to 4/5. Let's think about what this ratio is telling us. Tangent corresponds to our opposite and adjacent sides of our right triangle. In other words, the ratio of opposite and adjacent sides has to be 4 over 5. So begin by drawing a right triangle, and we can label one of the angles theta. And with respect to that angle theta, we know that the opposite side must be 4, and that the adjacent side must be 5. Well, if we want to find the values of the remaining trigonometric functions of theta, that will require us to have all sides of our right triangle. And we can find the hypotenuse of this right triangle by using the Pythagorean theorem. A squared plus b squared is equal to c squared. In this case, we have 5 squared plus 4 squared is equal to c squared, our hypotenuse squared. That is 25 plus 16. 25 plus 16 gives us 41 is equal to c squared. We take the square root of both sides, giving us c is equal to the square root of 41. That is the length of our hypotenuse of this right triangle. And now that we have all the sides of our right triangle, we can evaluate the 6 different trigonometric functions. Let's start off with the sine of theta. Well, how do we evaluate the sine of theta? We take the ratio of our opposite side divided by our hypotenuse. This gives us 4 divided by root 41. Now, we never want to leave radicals in the denominator of a fraction, and so in this case, we want to rationalize our answer. We can do this by multiplying by root 41 over root 41. Notice we are allowed to perform this operation because this is the same thing as multiplying by 1, which just does not change our value at all, giving us 4 root 41 divided by 41 for our final answer. All right, the cosine of theta. Well, to evaluate the cosine of theta, we take adjacent divided by our hypotenuse. This would be 5 divided by root 41. Again, we need to rationalize this fraction. To do so, we multiply by root 41 over root 41, giving us 5 root 41 over 41 as our final answer. All right, the tangent of theta. How do we evaluate the tangent of theta? We take the ratio of the opposite and adjacent sides. That gives us 4/5. And that's also good that that corresponds to our drawing because that's the given information. Yes? All right, our drawing should definitely reflect the information that is given. All right, so we've got sine, cosine, and tangent. Let's go to the reciprocal of our sine trig function. The reciprocal of sine is cosecant. Cosecant theta, instead of being opposite over hypotenuse, we flip that, giving us hypotenuse over opposite. Hypotenuse divided by opposite, the ratio of those sides of our right triangle gives us root 41 divided by 4. Notice in this case, the radical is already in the numerator, and we do not need to rationalize it. All right, the reciprocal of cosine theta, that is secant theta. That's going to be hypotenuse over adjacent. Hypotenuse over adjacent gives us root 41 over 5. And the reciprocal of tangent theta is cotangent theta. That's going to be adjacent divided by opposite, which gives us 4/5 for our final answer. Okay, all right, so there is evaluating our 6 different trigonometric functions using a right triangle. Now, this information can also be used to help us in solving sides of a right triangle if we only have one side. So let's take a look. It says, use the given values to approximate x and r to 2 decimal places. Find alpha as well. All right, so let's start off with finding x. We always want to utilize the given information as much as possible. We have this angle as being 58 degrees here, and the side that corresponds to that 58 degrees, well, is the opposite side. So I have 58 degrees, I have an opposite side, and we are trying to find the adjacent side to this 58 degree angle. Well, is there a trig function that relates opposite and adjacent sides? Yes, that would be our tangent trig function. The tangent of 58 degrees has to be equal to 30 divided by x, right? To evaluate the tangent of 58 degrees, we take the ratio of our opposite side divided by our adjacent side. We can now use this to solve for x. Notice x is here in the denominator. I would have to multiply both sides by x and then divide both sides by tangent of 58 degrees, giving me x is equal to 30 divided by the tangent of 58. And taking out our calculators and plugging this quantity into the calculator, we get x is approximately 18.75. Now notice, we are measuring these angles in degrees. This means your calculator must be in degree mode in order to obtain the correct answer. All right, so make sure your calculator is in degree mode. That's how we can solve for x. Now, that gives us 2 sides of our right triangle. And if we have 2 sides of a right triangle, we can find the third side using the Pythagorean theorem. Now, one reason we want to avoid doing that in this particular case is because x is an approximated answer, and if we got x wrong, all right, if we got x wrong, then we are definitely going to get the wrong answer for r. So instead, let's see if we can't use trigonometric ratios to help us solve for r. Again, always think about using the given information. Here I have a given angle of 58 degrees. I am given the opposite side, and r is the hypotenuse of this right triangle. Is there a trigonometric function that relates opposite sides and hypotenuse? Yes, that would be sine. The sine of 58 degrees has to be equal to 30 opposite divided by r, our hypotenuse. And to solve for r algebraically, we would multiply both sides by r and divide both sides by sine 58 degrees. R is equal to 30 divided by the sine of 58 degrees, which we can then plug into our calculator, giving us 35.38 approximately for our hypotenuse of our right triangle. Okay, so there we have x and r, and finally we must solve for alpha, this angle up in the top corner. Well, hopefully you guys recall from your geometry classes, the sum of all angles in a triangle must add to 180 degrees. Therefore, 90 degrees, that's our right angle, plus 58 degrees plus alpha must equal 180 degrees. I subtract 90, I subtract 58. That leaves me with alpha is equal to 32 degrees. There is our angle. All right, so there you have it. Using right triangle trigonometry to evaluate our 6 trigonometric functions of theta, as well as using that right triangle trig to help us in finding some of the sides of a right triangle.